Hi there, welcome to our demonstrational video of Capstone Information Security Project. The team members are Gagandeep Singh, Yashbir Nayal, Subhan Khan, Kamalpreet Kaur, and Mohammad Shahid. Let us begin with our presentation. So, let us first understand what is code injection attack. Code injection attack is basically an attack which involves inserting malicious code to exploit vulnerabilities and manipulate applications' behavior. Here are some popular code injection attacks. We can see that on the top we have SQL injection. This has been the most popular attack. Then we have XSS, that is cross-site scripting, OS command injection, remote code injection, and so on. These are some popular injection attacks. For this presentation, our main area of concern is SQL injection attack. Let us first look what SQL injection attack is, then we'll go further in the demonstration. Basically, SQL injection attack is where the attackers exploit into vulnerabilities in a web application by inserting malicious SQL query code into the application's input fields. We'll give you a demonstration about that for further clarity. The application executes that altered SQL query on the database server, and which attackers can use to extract the sensitive data, bypass authentication, or modify delete records, or whatever malicious activity comes to their mind, they can do that. Prevention involves securing code, parameterized queries, input validation, and regular updates. Now our practical demonstration starts. We can see that we will be hosting a website on AWS, and we are making it vulnerable by intention. We are not using firewall, and we are making it unsecure by intention. Now what we are going to do is we will do a successful SQL injection to our banking web application. The web application which we are hosting is, for demonstration, we are using a banking application. And later in the demo, we are going to show that make the banking application secure, especially from SQL injections. This will be the demonstration. The infrastructure and resources we're going to use are demo banking web application hosted on AWS EC2, creating a elastic load balancer and attaching EC2 with it, creating firewall and attaching it with our load balancer. This is our banking application, intentionally unsecured. You can see that it's not secure. I have also hosted it, so we will show you here that it's live. This is my banking application. I have hosted in on AWS load balancer. Basically, it's hosted on EC2. This is my EC2 where it's hosted, and my EC2 is later on attached to the load balancer. From the load balancer, I'm getting that DNS name, which we are pasting here, along with Altoro Mutual to get this login page of the banking application. Why we are using Elastic Load Balancer here? The answer is simple, because we are trying to replicate the exact real world scenario. Because any web application which is hosted in real world, in the background they use Elastic Load Balancers because they have the expectation of huge traffic coming anytime. And for that, Elastic Load Balancer serves the purpose of splitting the traffic as well as replicating the EC2 instances up to the requirement, which is high scaling and low scaling, which is not the topic of today. So we'll be focusing on the firewalls and EC2 only. Coming back to our presentation. So we saw our website, which has been hosted. We are trying to sign in using legitimate credentials. Here I'm using admin as credentials, and I can see that I have been logged in using admin credentials. I will show it live here today. Admin. Sorry, it's typo. admin. Yeah. And here I am logged in as a user admin. I'll log off again. Coming back to our presentation, that we can see that we have been successfully logged in using the legitimate credentials. Now I'm going to try using SQL query. Basically, this is a form of SQL injection which I'm going to perform. As we understood from our presentation, that SQL injection is basically nothing but putting SQL queries inside the parameters here in the username and password. These queries will run and go in the database and give the feel to the database that they have been matched. Like the username will be either this or 1 equals 1. The SQL query will feel like whether this is the username, it will say as no, it's not the username. Then it will function as 1 equals to 1, which will come out to be true. So in this case, when the database will give a true feeling, it will get us logged in. Here we can log in. So basically, this is the demonstration how SQL injection work. So here I have successfully got logged in using the SQL query. But now this is a very concerning thing. Here, this is in the presentation. I can see that I've been logged in successfully. What's the problem? The concerning thing is that SQL injection knowledge, people with SQL injection knowledge can do malicious activities. For example, in a banking scenario, the guy can do some transactions. Hacker can use this hack for his own benefit. Like he can do transactions into his own account, increase his balance, or hacker can be hired by competitive banks to destroy their competition. That's a normal scenario. So what we are going to do is we are going to create a firewall in AWS. The idea is to create a firewall with those rules which will safeguard our application from SQL injection. We will stop any login when the user is trying to get into by using SQL queries instead of valid credentials. Later attach the created firewall to where our application has been hosted. So this is the firewall which we created in our case. We can show you like how we created a firewall. Let me just show you in real time. Oops, that's not the one. I'm showing this you just for example's sake. So I'm creating a firewall and I'm adding some rules. There are rules which are AWS managed rule groups. Some of them are paid like $10 per month, but in our case, for stopping from SQL injection, we can get one from the free rule groups. Here in the SQL database, it stops us from getting attacked from attacks like SQL injection attack. So if I turn this on, later I add it and I create this as a web firewall, then this will work in our case successfully. I have already created one, which is right here. Yeah, right here. This is my firewall demo, WebACL. This is what I am showing in my presentation as my firewall, which has already been created. As I showed you right now that I have uh, I have started that firewall and I have given that rule of SQL injection inside it. So this is what we get. I'm showing that looking at the rules here, we can see that I have highlighted SQL injection attack and I've turned it on. Firewall and Elastic Load Balancer. We have hosted our application on EC2 and we have created Elastic Load Balancer. We attached the EC2 to Elastic Load Balancer and we later created firewall. Now we are going to attach this firewall to the ELB, Elastic Load Balancer, because the traffic will go through ELB and we have to put SQL injection block right there. Here I'm showing the EC2 instance where I've hosted the application. Elastic Load Balancer, this is InstaLB. In my case right now, I think I've changed the name, something else. Yeah, this is my load balancer right now. We can confirm, verify that it's the same one by passing Altoro Mutual slash Altoro Mutual, and here we are. So this verifies that we are using the correct load balancer here. So coming back to our presentation again. And I have shown you the WebACL firewall which we are using. Okay, so here we can see that there is no associated associated AWS resource with our web application firewall. Let me open my web application firewall. Where is it? I just opened it. Yeah, searching for it again. This is my web application firewall, which has been created with those rules of stopping SQL injection. And in the associated web resources, I can see that there's no attached resource. Now I'm going to do what? I'm going to do that. I'm going to attach it with that load balancer. And then we will check whether SQL injection works or not. We can see that it has been successfully associated with web application, with WebACL, with load balancer. So attach the ELB with firewall. Now trying to do the SQL injection again, and it failed. I will show you in real time. Altoro Mutual, this is my website. I'm going to do this SQL injection again. Oops. Just going to paste this query as the password also, and this should be forbidden. This is forbidden because now we have our firewall attached to the load balancer through which the traffic is accessing our website. So basically, we prove that we can stop SQL injections like this, and this is a step we took to make our application a little more secure. These are the results, conclusions, and learnings. We can see that our firewall stopped SQL injection from working. Firewall looks from SQL queries in the login bracket and makes them fail from getting logged in. We learned that what SQL injections look like. We learned what infrastructure behind web application looks like. We learned what can happen if our web application are vulnerable. Lastly, we learned how to attach firewall and what few things about what firewall can do. That was the end of our presentation. I hope you understood each and every concept of our demonstration through our presentation. Thank you for listening so carefully. And that's all. Thank you. Have a nice day.